So, hello everyone, let's solve max exam math A 2015 question 1.1. So he's telling us we have this 2x squared minus 5x for the values, and this is important, x bigger or equal to 1 and smaller or equal to 4. So where does it take its minimum and where does it take its maximum? Now 2x squared minus 5x, you might imagine that it's like here it's positive, so it is a happy parabola, right? So maybe it's like this, maybe it's like this, but the thing is that we don't take it everywhere. We are just concerned for the part from 1 to 4, okay? This, the rest is cut. We don't care for the rest, okay? Because x must be bigger or equal to 1 and smaller or equal to 4. So let's find some critical points important for us so that we can draw the function, okay? So the first thing, let's find where it cuts the x-axis, okay? The x-axis. Where it cuts the y-axis, it doesn't matter for us because x is always bigger or equal to 1, okay? So it doesn't matter for us. So how do we do this? Now look, we can take x over here, so it will be 2x minus 5, okay? This is the same, okay? If you multiply x, you'll get it back. So if we want to find where we are cutting the x-axis, we can say that this is equal to 0, okay? So this cuts the x-axis in 2 points, x1 equals 0 or x equals 5 divided by 2. Why? Because if x was 0, 0 multiplied by anything would be 0. And if x was 5 divided by 2, we would have 2 multiplied by 5 divided by 2 minus 5, which would be 0. And 0 multiplied by anything would be 0 too, okay? So this is why. So these are our solutions, okay? For the x, not the solutions for the question, but for where it cuts the x-axis, okay? Now what other critical points can we have? Well, uh, let's see the point where x is 4 and x is 1, so that we can see what it's happening. And the vertice, right? We can find both of them. So when x is 4, what is it happening? Let's see it over here. So we'll have 4 multiplied by 2 multiplied by 4 minus 5. So we will have 8 minus 5, which is 3 multiplied by 4, 12, right? So we have it when it is 4, the point it goes to 12, okay? What about when it is 1? So we will have 1 multiplied by 2 multiplied by 1 minus 5, okay? So we'll have minus 3. Minus 3? Wait. 1, 2, minus 5. Yes, minus 3. Just weird. Okay, so the point will be 1 and minus 3, okay? So what about the vertice? The vertice of this 2x squared minus 5x, okay? So if we want the vertice of this function over here, we can 5x, so it is minus b divided by 2a, right? So the x of the vertex would be 5 divided by 4. What about y of the vertex? Y of the vertex is what? Is minus delta divided by 4a, right? So it is, remembering that delta is b squared minus 4ac, but since c is 0, so this part is out. So by using the formula minus delta divided by 4a, we have that the y of the vertex is 25, negative, right? Negative 25, because of over here, divided by 8. Okay, so now let's try and draw our graph with these informations, okay? So first of all, what our graph start with the point 1, right? So what do we have in point 1? Well, we have this 1 and minus 3. So in 1 we will have 1 and minus 3 over here, okay? This is minus 3 and this is 1. And then we are going to have this 5 divided by 4 is slightly bigger than 1, right? uh, let me yeah, it's a it would be, one second, let me do this. 5 divided by 4, we have 4, 1, 2. Yeah, it would be 2, 2, something like this. You see, it is slightly bigger than 1. So, and minus 25 divided by 8 is, look, 8 multiplied by 3 would be 24, okay? 8 multiplied by 3 is equal to 24. So 25 divided by 8 is slightly smaller than minus 3, okay? So uh, let's let us call uh, this point over here is the point of the vertex, okay? The vertex. It is in 5 divided by 4, okay? 5 divided by 4 over here, okay? And it is slightly smaller than minus 3. So just so it makes more sense. So look, we have some points. 1 and minus 3 when we have it 1. 5 divided by 4 and minus 25 divided by 8. And the other point is 4 and 12, okay? So these are our critical points that we found. Now you might argue, why and this point over here, it cuts in the 0, but it doesn't matter because of here, okay? So how do we go on solving this? Now let me just put some colors. So this first color will be this color over here, and this one, this color. So now look, our first point is the red point over here, okay? So it is this point over here. Now 5 divided by 4, remember, it is slightly bigger than 1. It is slightly bigger than 1. And minus 25 divided by 8 is slightly smaller than minus 3. So it is this point over here. And 4 divided by 4 chooses 12. 4 is a bit over here, and 12 is over here, okay? So this would be our graph, okay? Something like this, okay? This point included. So look, the maximum point is this blue one. This is the maximum. 4 for the x and 12. The minimum is this one, okay? 5 divided by 5 divided by 4 and minus 25 divided by 8, okay? It was important for you to notice that minus 25 divided by 8 is slightly smaller than minus 3, okay? So it is lower. Okay, now I'm going to put it in the decimal so we can see it. I put the function over here of the quadratic and put it the values that x can go, and now we have it over here drawn. Look, you can see that this is the point of the minimum, and here is the point, and then it goes until here, 12 and 4 and 12, okay? So this is the function drawn. So, and the thinking that you need to have behind it is that usually it would have been a simple quadratic formula, a simple quadratic graph that would have the minimum in its vertices, and then it would go up to infinity, right? So this is why you need to calculate the values that he gave you, the value of the function in 4 and in 1, so that you can find this point over here and this other point over here, over here, and then you calculate the vertice, because maybe like if the vertex is in the interval, so the vertex would be the minimum, but maybe if the function was like from 2, from x bigger than 2, so it wouldn't be in the vertex, right? Because the vertex is not included. It would have been over here, but so this is it. Okay, so you find the vertex, you find the values in 1 and 4, the limits of the values of x, limiting x.